Welcome back, everyone. So now we're going to start talking about compositions of sine with sine inverse. And just before I do that, I'm going to write down again my restricted domain for sine, which was negative pi over 2 to pi over 2, and the range for sine, negative 1 to 1. So sine of x takes an input that's an angle in that restricted domain and gives me an output between negative 1 and 1. And sine inverse takes something between negative 1 and 1 and gives me an output that's an angle between negative pi over 2 and pi over 2. All right, so if we are talking about composing sine inverse with sine, and remember that when we're talking about composition of functions, we always evaluate working our way from inside out. So if we're thinking about sine inverse of sine of x, and if x were in this interval from negative pi over 2 to pi over 2, sine would take that value and give you a number between negative 1 and 1, and then sine inverse would bring you back to the start again. You'd get your original value back of x. And if you were taking a value between negative 1 and 1 and putting it into the inner function here, sine inverse would take your number and give you an angle between negative pi over 2 and pi over 2, and then sine of that would return you back to where you started. So again, sine of sine inverse would bring you back to x, and there you go. So for the next two problems, these are both fairly straightforward. The number that we're putting into sine inverse, 0.2, that is in the domain of sine inverse from negative 1 to 1. So that 0.2 will be taken by sine inverse and given transformed into an angle between negative pi over 2 and pi over 2. And sine will bring us back again. So when we take that 0.2 and put it into sine inverse, and when we put that into sine, we will get our original value of 0.2 back. Now for the second part, sine inverse of sine of pi over 6, this is where we remember that pi over 6, that would be an angle that is in that interval from negative pi over 2 to pi over 2. So sine will take that and give you a number between negative 1 and 1, and sine inverse will return us back to where we started. So that means that for sine inverse of sine of pi over 6, the answer should just be pi over 6. Now things get a little bit more complicated when we have the inside function being given a value that's not in its domain or not in its restricted domain. So there's two different cases to consider. One is, what if we were to put something that wasn't in the domain of sine inverse into sine inverse? And that one's the easy one, because if you took something that wasn't in that interval from negative 1 to 1 and put it into sine inverse, well, sine inverse would not be defined. So, and that would mean that sine of sine inverse would also have to be not defined or undefined. The other one is not as straightforward, because remember, even though we've restricted the domain for sine to be from negative pi over 2 to pi over 2, that doesn't mean that we can't still evaluate sine outside of that interval. So if we were to, for example, look at something like sine of sine inverse of x, if x wasn't a number between negative pi over 2 and pi over 2, you could still evaluate what sine of x is. It'll still give you a number that's between negative 1 and 1. But remember that sine inverse will only give you angles between negative pi over 2 and pi over 2. So if your input that you gave wasn't in that interval, you will not get your same output back that you put in. Now, the thing here that we can do to finish the problem is, if we're looking at an angle that's not in quadrant 1, not in quadrant 4, so some angle that's not between negative pi over 2 and pi over 2, then what we'll have is, instead of getting the angle that we put in back, we'll get a different angle here that I'm calling theta. And theta will have to be something that's in quadrant 1 or quadrant 4, because of course it's the output of sine inverse. And where that angle theta has the same value for sine that x did, our input value. So let's do some examples. The first one is the one that's the straightforward one. Here we're looking at the inner function being sine inverse, and we know that the domain for sine inverse is from -1 to 1, and so since that's not in the domain, then sine inverse of 1.3 is undefined, and if sine inverse of 1.3 is undefined, then sine of sine inverse of 1.3 is also undefined. So the answer here is just that it is undefined. There we go. For the second one, sine inverse of sine of 9 pi over 10. So for this next one, I'm going to start off just quickly by sketching the angle. The inner function is sine, and I can always put a number in for sine. That 9 pi over 10, though, that is not an angle that is in my restricted domain from -pi over 2 to pi over 2. 9 pi over 10, if I'm thinking about this 180 degrees or pi, that is the same thing as 10 pi over 10. So that means that 9 pi over 10 should be a little bit above the x-axis. And if 9 pi over 10 gets me a little bit above the x-axis and 10 pi over 10 gets me to the x-axis, then my reference angle must be pi over 10. So here's my angle of 9 pi over 10 and my reference angle pi over 10. Now, the problem here, of course, is my angle is not in quadrant 1 or quadrant 4. If my angle was between -pi over 2 and pi over 2, then whatever I put into sine inverse would give it back to me. But here I'm putting in an angle that's in quadrant 2. And so the next thing that I need to think about is, sine of that angle, is that positive or negative? And if I'm thinking about the quadrant that I'm in, that's quadrant 2, there sine is positive. So I know then that sine of 9 pi over 10 should be the same thing as the equivalent angle in quadrant 1, where we're also positive for values for sine. So sine of 9 pi over 10 should be the same thing as sine of pi over 10. And since that's true, since 9 pi over 10 and pi over 10 give me the same value for sine, and since pi over 10 happens to be in my restricted domain for sine, then that means that sine inverse won't give me 9 pi over 10 as the output, it'll give me pi over 10 as the output. So notice here that what happens, I put in an angle that's not in quadrant 1 or quadrant 4, but sine inverse will give me an equivalent angle, one that gives me the same value for sine, that is in quadrant 1 or quadrant 4. Our angle was in quadrant 2, where sine is positive, so the angle sine inverse gives me back has to be in a quadrant where sine is positive, and that would be quadrant 1. And so then sine of 9 pi over 10 and sine of pi over 10, they were equal, which means that pi over 10 would be the output that I'd get from sine inverse. All right, one more. Let's look at sine inverse of sine of 15 pi over 13. And I'm going to do the same thing that I did before, which is to start off by drawing an angle. I know that if, again, I'm thinking about pi, if I'm thinking about that negative side of the x-axis, at pi, that would be the same thing as 13 pi over 13, which means that the 15 pi over 13 that we're looking at must be 2 pi over 13 past the x-axis. So here's my angle of 15 pi over 13. 13 pi over 13 takes me to the x-axis, and 2 pi over 13 takes me to that terminal side. Okay, so there's my angle, and I know that I'm definitely not in quadrant 1 or quadrant 4. Remember that that's the restricted domain for sine. We are in quadrant 3, and in quadrant 3, that's a place where sine is negative. Tangent is positive here, everybody else is negative, so I know sine of 15 pi over 13 will be some sort of negative value. Now, in quadrant 1 and quadrant 4, it's quadrant 4 where sine also has negative values. So the angle that we're going to be looking at will be the one that's in quadrant 4 and has reference angle of 2 pi over 13. So that must be the angle negative 2 pi over 13. So sine of 15 pi over 13 and sine of negative 2 pi over 13, that they would both have the same value for sine. And negative 2 pi over 13 happens to be in my interval, in my restricted domain from negative pi over 2 to pi over 2. So that means that sine inverse, when I give 15 pi over 13 into sine, sine inverse won't give me 15 pi over 13 back. It will give me negative 2 pi over 13. All right, excellent. Now, the next part is talking about inverse cosine functions, and a lot of this is, again, similar to the things that we'd said about inverse sine. Here, we're restricting our domain to quadrant 1 and quadrant 2, and the reason for that is if we had used quadrant 1 and quadrant 4, those are both quadrants where cosine is positive. We wouldn't be getting the full range of cosine, and in fact, we'd be getting the same y values twice in these quadrants. So instead, we choose to use quadrant 1 and quadrant 2, so between 0 and pi. That's our restricted domain for cosine, which means that that will be the range that we'll have for cosine inverse. Other thing that's similar as well is just as before with cosine inverse, the notation we could write cos with a little -1, or we could write arc cos, the arc cosine function, and those are both equal to each other. So same thing how sine inverse of x and arc sine of x were both equal to each other. Same thing here, cosine inverse of x and arc cosine of x, they are equivalent to each other. Now, same thing as well, just as the relationship was between sine and sine inverse, the same relationship holds between cosine and cosine inverse. If you put pi over 4 into cosine, you'll get root 2 over 2 out. And so that means if you put root 2 over 2 into cosine inverse, you'll get pi over 4 coming out. Domain and range, again, same thing that we said before, so I'll just sort of speed over this part a little bit. Because the domain for cosine, we're taking it to be the restricted domain of 0 to pi, that means the range of cosine inverse will be between 0 and pi. And that's because whatever the domain is for one function, that's the range for its inverse. And since the range for cosine is between -1 and 1, that means the domain of cosine must be, inverse must be between -1 and 1. And same thing that I'd said about the graph of cosine versus cosine inverse, how it takes x and y coordinates and switches them. So for example, the point that we have here at the bottom of the cosine graph, that's the point pi -1, there's the equivalent point on the cosine inverse graph where it switches the x and the y coordinates, -1 and pi. All right, let's do some evaluating of inverse cosine functions. Cosine inverse of 0, I mean, if we're remembering our cosine graph, we know that cosine has a value of 0 at pi over 2, that cosine of pi over 2 is 0. So since cosine of pi over 2 is 0, then that means cosine inverse of 0 must be pi over 2. Next one, cosine inverse of -1. So we know, if we're thinking back again to the graph, for -1, that's exactly the point that I have labeled. When the angle is pi, cosine has the output of -1, or in other words, cosine of pi is -1. So arc cosine of -1, which is of course same thing as cosine inverse of -1, that should be pi. Let's do some more. Cosine inverse of root 2 over 2, negative. So this is a number hopefully we're remembering from our special triangles. Remember that for the 45, 45 and 90 triangle, that the side lengths are 1, 1, and root of 2. And that when you're looking at cosine of pi over 4, cosine of of 45 degrees, you get adjacent over hypotenuse 1 over root 2, which of course simplifies to give you root 2 over 2. So we know that cosine of pi over 4 gives us root 2 over 2. Now, we're not looking at root 2 over 2. Here we're looking at negative root 2 over 2. And we remember that for the cosine function, we restricted its domain to quadrants 1 and 2. Quadrant 1, that's where it's positive. Quadrant 2, that's where it's negative, which means that the angle that we're talking about will be in quadrant 2. The reference angle will be pi over 4. So that means the angle that we're talking about is 3 pi over 4. So I'm just going to summarize up here. We can say we knew that cos of pi over 4 was root 2 over 2. And now we've just discovered for ourselves that cosine of 3 pi over 4 is negative root 2 over 2. And so cosine inverse of negative root 2 over 2, well, that would be 3 pi over 4. There we go. Because, of course, the relationship is, since cosine of 3 pi over 4, as that input gave us negative root 2 over 2 as its output, then cosine inverse with negative root 2 over 2 as its input should give you 3 pi over 4 as its output. Last one, cosine inverse of negative 0.2. Negative 0.2, that's negative a fifth. That's not something that I would get from one of my special triangles. I would get root 2 over 2s or a half or root 3 over 2. So that's my hint that I guess for this one I'll need to use my calculator. Same thing that we did before. First, remember that you have to check to make sure that it's in radians mode, and then second function, cosine button, negative 0.2, and when I run that through my calculator, I get about 1.77215, or if we were to round that off to 3 decimal places, 1.772. All right, wonderful. So we'll take a pause here, and you can just refresh yourself, take a few minutes, get yourself a new cup of tea. And when we come back, we'll do the same sort of thing that we did at the start of this video, looking at compositions of cosine with cosine inverse. And then at the end of the video, we will also talk about tangent inverse. So we'll see you all in a few minutes.